In the previous video, we discussed dummy coding 3 or more groups and then examined some multiple regression output for simulated data where we were predicting verbal SAT scores based on 4 different types of academic programs. We got through the ANOVA and model summary table, and now let's spend a few minutes going over the coefficients table. There's a lot to see on that one, all right? So here we are. Here's our regression model, the actual coefficients. We'll focus on the unstandardized coefficients, and we can write out the regression equation as a student's predicted verbal SAT score is equal to 460.101 plus 80.792 times their math curriculum dummy code, plus 71.472 times their language curriculum dummy code, plus 45.241 times their intensive curriculum dummy code. That's our regression model. Now, if I want to predict the score for a student in any of the different programs, I just plug in the corresponding values for each of the dummy codes and solve the equation, right? So let's start with someone in the standard curriculum. If someone's in the standard curriculum, are they in the math curriculum? No. So I'll plug in a 0 for the math curriculum dummy variable. Would they be in the language curriculum? Nope. So I'll plug in a 0 for the language dummy code, right? And are they in the intensive curriculum? Still no. So I'll plug in 0 for it as well. That makes the regression equation 460.101 plus 80.792 times 0 plus 71.472 times 0 plus 45.241 times 0, right? Well, all of those times zeros are going to drop out, so it just reduces to the predicted verbal SAT score for students in the standard curriculum being equal to the intercept, or the constant, which is 460.101. The intercept is the predicted score for someone in the standard curriculum. And if we think about it for a minute, that makes sense, right? Because what is the intercept? It's the predicted outcome value when your score on all of the predictor variables is equal to 0. In this case, when you're a 0 on all of our predictor variables, all those dummy codes, you're in the standard curriculum. And notice, if we check the descriptive statistics from a previous video, we see that this is also the mean for students in the standard curriculum. In a simple model like this, where the only thing we have is our categorical variable, the predicted score for a group is the mean for that group. And if we think about that, that also kind of makes a lot of sense. If I don't know anything else about a person other than that they're in the standard curriculum, what would I want to predict for their score? The mean for that group, right? Remember, I don't know anything else about them, so I can't adjust or statistically control for other variables that may also influence their score. And sure enough, the predicted score for a student in the standard curriculum is the mean for students in the standard curriculum. It worked. Great. Right? And remember, we noted that the standard curriculum will be our referent group. Now, why it's our referent group will be clear in a minute. All right? Now, let's look at some other information in the coefficients table. There's, of course, the t-test. Remember, it's testing the regression coefficient in the population and seeing whether it's equal to 0. In this case, as we just saw, the intercept is the mean for the standard curriculum. So this test is testing whether the mean for the standard curriculum in the population is different from 0. And what did we find? Does our t-test indicate that the mean for the standard curriculum out in the population is not equal to 0? Well, of course it does. The average SAT for any program will be higher than 0. You can't even get a 0 on the SAT. Now, because it's often a silly or uninteresting analysis, the t-test for the intercept or constant is often not particularly interesting, but we'll actually talk about doing something about that in future videos. All right? Now, on the other hand, the 95% confidence interval may be very interesting. It gives us an estimate of the range in which we would expect to see the true mean for the standard curriculum in the entire population. In this case, our point estimate is exactly 460.101, but we're 95% confident that the true mean across everyone in the population who receives the standard curriculum is somewhere between 427.075 and 493.127. Right? Now, let's move on. What about students in the math-focused curriculum? What's their predicted score? To get that, we do exactly the same thing. Here's our regression model, right? We just plug and chug. If you're in the math-focused curriculum, your predicted score will of course include the intercept, right? Now, are you in the math curriculum? Well, yes now. So I'll plug in 1 for the math curriculum dummy code, right? Would you be in the language curriculum? Nope. So I'll plug in 0 for the language dummy code variable. And would you be in the intensive curriculum? Nope. So I'll plug in 0 for that one as well. All right? That gives us our predicted SAT score is equal to 460.101 plus 80.792 times 1 plus 71.472 times 0 plus 45.241 times 0. Right? Our equation for predicting the scores for students in the math curriculum is just plugging in the dummy code variables based on which group you're in. Right? Now, those last two coefficients where we're multiplying by 0, right? Well, they're just going to drop out, right? And this will reduce to 460.101 plus 80.792, which solves to 540.893. Our predicted score for students in the math-focused curriculum is 540.893. And what's that? It's the mean for the math-focused curriculum within rounding errors, right? Excellent. Again, in this simple model with only our categorical variable as a predictor, the predicted score for students in the math-focused curriculum is the mean for the math-focused curriculum, exactly what we think it should be given we're not adjusting for anything else. But let's take a step back and look a little more closely at the math coefficient. Notice the math coefficient is equal to the difference between the math-focused curriculum and the standard curriculum. You see that right here, don't you? We're taking the intercept which is the mean for the standard curriculum, our referent group, and we're adding 80.792 to it. The 80.792 is the coefficient for the math curriculum effect. It's the math curriculum effect, right? It's how much higher or lower the math curriculum mean is relative to the standard curriculum. That's why the group coded 000 is called our referent group. It's the group that our dummy code coefficients are referencing. It's the group their effect is being compared to. The dummy code coefficients tell us how large the difference is between the group associated with that dummy code and the referent group. Now, with that in mind, what does the t-test for the math curriculum coefficient tell us? Why don't you pause the video for a moment and think about it. Restart once you have an idea in mind or just feel a little stumped, all right? Well, remember, the t-test is examining whether the value for that coefficient in the population is equal to 0. If the coefficient is the difference between the mean for the math curriculum and the mean for the standard curriculum, the t-test is testing whether the mean for the math curriculum in the population is different from the mean for the standard curriculum in the population, right? So what do we see? Well, we see that the mean for the math-focused curriculum is significantly different from the mean for the standard curriculum, with a t with 396 degrees of freedom equal to 3.401 and a p-value of 0.001. And remember, we're talking about the means in the population for everyone who gets these academic programs. Right? And while our specific point estimate of the size of that difference is 80.792, we're 95% confident that the true difference between the math-focused curriculum and the standard curriculum in the entire population is somewhere between 34.086 and 127.497. The true difference in means across the entire population is likely somewhere in that range of scores that we see with our confidence interval. Now, with that, let's stop this video, okay? In our next video, we'll look at the effects for the language-focused curriculum and the intensive curriculum. See if you can anticipate how we'll interpret them, what kind of comparisons and statements we'll be making about their effects. Okay? See you then. Take care.